Hey there, how's it going? I'm going to go over my method for diagnosing a glass cooktop without having to take the top apart and get to the element. The customer's complaining about the element not heating or just the outside ring. So I want to test everything from that switch back there. And after I did some research, I found out that these are going to be my test points number 2, 4A, and 4 for the inner and outer coil. It's going to be real important that I remember those when I go back and check my schematics here. So what I wanted to do here is just go over a parts breakdown with my pre-diagnosis and just see what I'm dealing with here. And also I want to check resistance on this burner so I know what's going on, what my readings should be. I'll notice when I pull it up, the resistance is not available. So what I have to do here is I check and I find out that it's a 3000 watt heating element. So what I'm going to have to do there is convert that 3000 watts into resistance with my Ohm's law calculator. That way when I take my readings, I know what I'm looking at the switch, and it'll guarantee and tell me what's working or what's not, or what's broken in the circuit. So this was the first drawing that I did off the schematic here, and I preferred this one over here. It was laid out a little bit more simple, but it lays out the 4A, the 4, and the 2 like we saw there earlier. And I'm going to take my readings off of each one. I'm going to leave it on the 2 all the way back to that infinite switch, through that high limit, through the inner coil, again through the outer coil, and check the resistance on each of those to find out if it's broken or if it's not. And then once I get the resistance, I'll take that on my ohms calculator and convert that into the watts and see if it adds up to that 3000 watts that we saw earlier. So this is the 4A outer coil I'm taking a reading on, and there goes 34.5 ohms. Again, I'm just kind of going back here on the diagram to double check, but that is my outer coil all the way through the temperature limit switch, all the way to the infinite switch. Now here is going to be the inner coil. That's just number 2 disconnected. They're all disconnected and the power's off. There's the inner coil 4, and when I check it here on my meter, open line. So I know that I don't have a complete circuit there in the inner coil, and the first one had 34.5 and this one has 0. So I'm going to convert that 34.5, see what that wattage is, and see how far off we are from that 3000 watts. Again, there I am at 34.5, and that's what I'm going to go by as my base. So once I put that in my ohms calculator and plug in the numbers, 240 volts, we know our resistance 34.5, and we have about 1670 watts, somewhere rounded in there. So we're short. So when you subtract the difference from that, that's what we're missing out of that 3000 watts on that coil right there between these 2 points. So I know for a fact that I'm missing right there between 4 and 2, that it's broken there. So I'm able to determine that there's a defective heating element without taking that apart. And if I needed to at that point, if it tested good, then I can check power and seeing if it's working or delivering out to that heating element. But this turns out to be the conclusion here on this diagnostic.